Hi kids! So for the third part of your analytical techniques and instrumentation, we will be discussing all about your luminescence, chromatography, and your mass spectrometry. So third part, kasi po, if you could still recall, the first analytical techniques that was discussed to you was during your CC1 laboratory, which is all about your spectrophotometry. And then the second part is your electrophoresis. Then this will be your third part. So, bali, for our discussion, expect that there will be a lot of videos that you will be watching. Since we are talking about instrumentation here, and actually, very technical manggod kaayo ni siya na topic na mo-discuss ta og components, mo-discuss ta og function sa taga-component, and kung unsa ang overall process na ginabuhat sa inyuhang mga kanina mga methods and principles. So, naisip na ako na at least you would get an idea and you could also imagine what these principles are really doing. Okay, since during our work or during your internship, when you are able to use machines, di ba dili biya gyud na ninyo makita kung unsa ang work inside that machines, which mo magyud ni ang ato ang mga analytical techniques and instrumentation is all about. So mo na again, a lot of videos will be presented. Taas na siguro kayo ng 5 minutes pod. So, I do hope na the same sa ako ang na-feel na while watching those videos, nalingaw po ko, kaya at least nakita po na ako na ingani gyud ang whole na process. So, I do hope na ma-enjoy po ninyo siya. So, for our objectives, so we will be discussing the general principles, what are the limitations of each of your analytical techniques, compare and contrast your analytic techniques, and then relate it to your different clinical applications or kung unsa man ang mga certain na substances na pwede nato gamiton para ato na certain na method or principle. So start na with your luminescence. Now, what is luminescence? So, from the word itself, di ba, luminescence, from the word lumen, so you would get an idea that we are talking about light here. So, basically, luminescence is the emission of light by a substance. And this emission of light actually occurs when an electron returns to the electronic ground state from an excited state and loses its excess energy as a photon. Now, for this statement, so we'll explain this further later via a video. Okay, para again, ma-picture out ninyo more sa man gyud yung mga excited state sa inyong electron, ngano na man gyud ma-lose na energy and all. So, we'll explain that further later. Now, luminescence has three types. You have your fluorescence, your phosphorescence, and your chemiluminescence. So, for the next, that would be your video. So, kindly watch this first.
Electrons move around the nucleus of an atom in concentric orbits. These orbits or shells represent different energy states that electrons can exhibit. The farther an electron is from the nucleus, the greater its potential energy. While electrons typically remain in their prescribed orbital energy level, it's possible for an electron to be knocked from its lower orbit into a higher one. Thus, a bombarding free electron can collide with a bound electron, raising it to a higher orbit or energy level. This electron is now in a state of excitation. However, this higher orbital status is fleeting. The electron will be quickly drawn back toward the nucleus and return to its original orbit. During this transition back to its normal state, a single photon of visible light is emitted. This repeating sequence of electron excitation followed by de-excitation is the basis for the functional capacity of a fluorescent light bulb. A typical fluorescent bulb is filled with argon gas and a minuscule amount of vaporized mercury. The inner surface of the tube is coated with the powdery phosphor substance. At each end of the tube is an electrode with filaments. When heated to a high temperature, they emit or boil off electrons. An AC voltage pulse supplied by a starter pushes the electrons from one end of the tube to the other. If one of the free electrons collides with an electron of the mercury vapor, the electron is bumped from a lower to a higher energy level. The electron quickly returns to its lower energy state and in the process releases an ultraviolet photon. This photon is then absorbed by the electrons of the phosphor powder lining the tube, again exciting electrons in the process. This excitation is followed in turn by de-excitation and the release of a low-frequency photon. The photons from all these reactions combine to produce the glow of white light, characteristic of fluorescent bulbs.
Okay, so just to explain further the video that you have watched, so as you can see, there are some substances that when you, kumbaga kung hatag mo og heat sa iyaha, it will absorb the heat and then gets excited. Na in a way, from its normal orbit, it will jump off to another orbit. Pero syempre, dili man na niya forever na i-carry ang katong certain heat or certain na energy na iyang nakuha. So therefore, there will come a time na mubalik siya dito sa iyahang orbit and syempre sa pagbalik niya sa iyahang original na orbit, kailangan man gyud to niya i-give off ang katong energy na once na na-observe niya. So upon giving off that energy, sumoto siya ang ato ang light emitted. Na actually, this is the basic principle for your luminescence. Now, what we are trying to look at is, again, the emitted light. So start with your fluorescence. Now, when a beam of light is incident on certain substances, they emit visible light or radiations. Now, it starts immediately after the absorption of light and stops as soon as the incident of light or the incident light is cut off. So, murag ang ani ang fluorescence. Now, ang ginamin ng aning second na statement ninyo, 'di ba na, it starts immediately after the absorption of light. By the time na naamoy i-introduce sa iyaha, just like what you can see here in this photo, na the upon directing that light into your substance, it will immediately absorb it. Pero by the time na tanggalon pud na ninyo ang light source, mawala lang po dayon to inyuhang incident light. So, ingana na ang whole process sa inyuhang fluorescence. So, how about your phosphorescence? So, unsa ang difference niya with your fluorescence? Now, phosphorescence is also known as your delayed fluorescence. Now, why is it called delayed? When light radiation is incident on certain substances, they emit light continuously that even after you cut off the incident light, it will remain. Okay, di ba? As mentioned a while ago, fluorescence is immediate emission of your absorbed light. Phosphorescence is delayed. So, kaya otherwise known as your delayed fluorescence. So, imagine this one. Take a look at this image. Diba, by the time na naamoy incident light, or naamoy light, radiation, or unsa man na i-render ninyo padulong dito sa inyuhang substance, i-absorb to niya na energy. Now, by the time na tanggalon to ninyo na source, it will continue to glow. So, murag kani sa inyong image, it will continue to glow or it will continue to absorb that light. Pero syempre again, longer period of time lang na ma-absorb to, but if you give it some time, bumalik gihapon siya into its original na itsura. It's just that if butangan man nato og time, si fluorescence siguro immediate man, so zero. Si phosphorescence, it would take about siguro how many minutes, or it could take up days. So to further explain, the difference between your fluorescence and phosphorescence. So another video will be presented, so kindly take a look at this one.
Explain the principle of fluorescence and phosphorescence. Many compounds absorb ultraviolet or visible light and undergoes electronic transitions from low electronic energy level to high electronic energy levels. This absorption of light requires 10 to the power minus 15 seconds. The instant re-emission of the absorbed energy is called fluorescence, while the delayed re-emission of the absorbed energy is called phosphorescence. For most molecules, the electrons are paired in the ground state. That is, pair of electrons have opposite spin. This is called singlet state. As the spin is paired up, they do not show any magnetic moment. But if the electrons have the same spin, the magnetic moment of both the electrons gets combined and they behave like a tiny magnet. This state where the electron pair is having same spin are called as triplet state. In molecule, there are several electronic energy levels and electrons are present at the ground state in the singlet state, that is, with opposite spin. When molecules absorb UV or visible light, one electron from ground state undergoes to an excited state. Now, excited state is also having several vibrational levels. So, the excited electron loses its energy by intermolecular collision and it comes to the lowest vibrational level of excited state. Finally, the electron from the lowest vibrational level of excited state return to ground state by emitting the radiation or light of lower energy or higher wavelength. This overall process of absorption, intermolecular collision and emission takes 10 to the power minus 4 to 10 to the power minus 8 seconds, which is very small. Thus, it looks like instant re-emission of light. But the energy of radiation emitted is always less than the energy of radiation absorbed. Or, in other words, wavelength of emitted radiation will be always higher than the wavelength of radiation absorbed. This is fluorescence phenomena. In case of phosphorescence, the inversion of electron spin takes place. That means when the energy from UV or visible light is absorbed, the electron from the ground state jumps to excited state. At the same time, the spin of the electron gets reversed and it is now in triplet state. That is, both electrons have same spin. In triplet state, there is less chance of electron coming back to ground state because pairing of electron with same spin is not favorable. Thus, it takes more time to reverse the spin and come back to ground state. The time taken by electron is from 10 to the power minus 4 to several seconds. Thus, it seems that the emitted radiation is delayed. In some cases, even when we turn off the light source, radiation keeps on coming. This delayed re-emission of radiation is called phosphorescence. Here again, the energy of radiation emitted is always less than the energy of radiation absorbed. Or in other words, wavelength of emitted radiation will be always higher than the wavelength of radiation absorbed.
Okay, so just to reiterate the one explained in the video, so ito po yun. 'Di ba? This further explains why fluorescence is uh, immediate immediate emission of light, the emission of light, while phosphorescence is delayed. So remember the terms katong inyuhang singlet state to triplet state. So that is actually very important. As to the reason why a certain substance would be converted from singlet to triplet state, again, it's a matter of ano na lang pod siguro, property na pod sa inyong substance. Kay naman dyan uban substance na phosphorescence ang gina-undergo na uban substance na fluorescence lang pod. So, bali, katong process, the process that involves katong transition sa inyuhang electronic state na from single to triplet state, take note of the term kani intersystem crossing. So that is what we called na katong transition from a single to triplet state na 'di ba having different state of spin. And that is actually the main reason why your phosphorescence kay delayed. Kay it takes some time before nakatong triplet state ninyo, kay 'di ba same ang spin, it takes some time na mobalik siya sa iyahang original spinning na opposite. So that is why there is a delay na re-emission sa inyuhang light. So I hope that is clear. Now, how to measure fluorescence? What do we use in order to be able to know kung pila gyud tong or naa gyud tay certain level na makita sa katong mga re-emitted na light dito sa inyuhang fluorescence or actually even phosphorescence kani po na siya ang way to measure. That is what we call your fluorometry. So let me just read the definition of fluorometry. Now, fluorometry measures the fluorescence or the energy emission that occurs when a certain compound absorb electromagnetic radiation, become excited, and then return to an energy state that is usually higher than their original level. Now, the emitted fluorescent light actually has longer wavelength and lower energy. Now, it is due to the energy loss between the time when a photon is absorbed and when it is emitted. So again, baliko na ako, katong emitted na light, longer ang wavelength and lower ang energy. And the reason for that, it's because of the energy loss that had happened between the time na inyuhang naka-absorb mo og photon and between the time na na-emit na to siya na certain energy. So what are the basic components of your fluorometry? So first, of course, kailangan nato og light source. Light source can either be your mercury vapor lamp or your xenon arc lamp. But between the two, what is commonly used is actually your mercury vapor lamp. Next, now, ang naka-unique sa inyuhang fluorometry actually is that it is composed of two monochromators. So, remember the purpose of your monochromator, di ba? From the word itself, monochromator, meaning isa ka single na color. And isa ni, di ba, ang ginabuhat sa inyuhang monochromator is to, kumbaga, from a wide range of colors, iyahang i-narrow down ang katong individual na color or wavelength na i-select nato. Di ba mo man na siya ang gi-discuss sa inyo ha during your spectrophotometry na discussion. So, the primary monochromator here in your fluorometry, otherwise known as your excitation monochromator, it selects the wavelength that is best absorbed by the solution to be measured. So, mo na siya ang iyahang purpose. Next is your cuvette. So, I guess you all know the purpose of your cuvette. That is your sample holder. And then we have your secondary monochromator. Secondary monochromator, also known as your emission. Now here in your secondary monochromator, it filters out fluorescence from your stray light radiation and it is positioned at a right angle from the cuvette to eliminate potential interferences from your excitation light. So, bale sa primary monochromator, during this time, kaya ni siya ginatawag na excitation because during this time, kumbaga murag gina transform pa nato ang ato ang substances or molecules into its excited state. For the secondary monochromator, this time around, what we are trying to capture here is your emitted light already. So thus, it is also known as your emission monochromator. And lastly, dili mawala inyuhang photodetector. Now here in your fluorometry, the commonly used photodetector is actually your PMT. So sa gani meaning ni PMT, diba that is your photomultiplier tube. Kay si PMT man jud actually ang naay diba murag highest or better sensitivity compared to your other photodetectors. So, if we try to draw your fluorometry, ingani ang iyahang setup. So again, you have the primary filter here and your secondary filter is positioned at a 90-degree angle. So basig matingala mo, ma'am, what is attenuator? Attenuator is just another term for your entrance slit. Now, nga siya nakaposisyon to 90 degrees, ma'am, nga dili man directly diri ang secondary monochromator. Remember here is your transmitted light. And di ba, dili biya transmitted light ang atong ginatry og measure diri sa inyuhang fluorometry. That is your emitted light. And emitted light is not actually directly dira na gina-release directly from your sample holder, dili na siya straight line. Usually it is emitted here na side sa inyuhang substance. And thus, your secondary filter is being placed below. Now, these are just examples of substances that can absorb light or can cause fluorescence. So, take note lang po ani nila, kaning POP. POP stands for your phenyl oxazole benzene. And then you have your quinine, your fluorescein, your acridine orange, your rhodamine B, and your pyridine 1. So again, these are just examples of your substances that could cause uh, fluorescence. And another thing, the kids, the atom or molecule that cause fluorescence or that fluoresces, ang term na ginagamit din nato ana is fluorophore. So let me write it here. That is fluorophore. So again, fluorophore, it is the atom or molecule that fluoresces. Okay? So what are the advantages of your fluorometry? Number one, it has increased sensitivity, 1,000 more times sensitive than your spectrophotometric method. Next, the reason for this, the reason behind as to why it has increased sensitivity, it's because the emitted radiation is being measured directly. Next, increase specificity by selecting the optimal wavelength for both absorption and fluorescence. Yun siya. And in addition also, fluorescence actually measures the amount of light intensity present over a zero background. So, very important po ding at least natin zero background kay as far as I could recall, when we say na ay zero background, lesser ang interferences na mahitabo. So, kato siya. So, for your disadvantage, the disadvantage of your fluorometry is that it is very sensitive to environmental changes. And the problem with changes to the environment while processing or while trying to measure your substance using fluorometry is this what we call, this term na what we call quenching. Quenching means there is a quick disappearance of your fluorescence. Quenching may happen if there are changes in the pH that could affect electron availability, or it could happen if there are changes in your temperature causing na naay loss of energy, or if naay contaminating chemicals or naay change sa solvent, then it may also change the structure of the substance being measured. And lastly, the UV light used for excitation could also cause photochemical changes, especially if dili gyud siya gina-calibrate or gina-change every now and then. Mga machines biya ninyo na ay maintenance and calibration every now and then na ginabuhat to prevent such thing to happen. So muna na dili kaayo ginagamit gyud or dili ang anak ka famous si fluorometry in terms of kaning use nato karon sa modern days. Next, so another example for your luminescence is your chemiluminescence. Na actually diri ko nalingaw kids kay ma-remember kaayo na ako si glow stick during my during my younger days. Char mura jud tiguang na no. During my younger days na labi na kanang kalag-kalag, 'di ba? Hapit namang gyud ta November. Na usually when we go to the cemetery to visit lagi ana kani gyud ang uso kayo na baligya. And 'di ba? What we usually do with a glow stick is that we usually break it para mag-glow. So, mao na inyo makita ani na video na naa sa bottom left ninyo na in order for your glow stick to actually glow, kailangan pa siya i-break. And ang kaning principle behind na ngano mo glow inyuhang glow stick, ngano kailangan na i-breaking na buhaton, that is actually your chemiluminescence. So, chemiluminescence is the production of light from a chemical reaction. So take note, keyword ninyo gyud diri is kani chemical reaction from the name itself kaning na ay chemi na kaya na ay light na ma-produce because of the chemical reaction that had happened inside. Now, reaction, here, the chemical reaction that happens here in your chemiluminescence is your redox reaction, and usually what is being used or mga common na substances that na kanang pwede mag-light, mag-cause of production of light is your luminol, your acridinium esters, your dioxetanes. Other examples pa actually na mas common, kaya basig mo na ma'am, asa man makakuha luminol and such. Actually, ang isa sa mga common po, pwede si oxygen, pwede si hypochlorite, and actually pwede po din yung hydrogen peroxide. So, characterized by a rapid increase in intensity of emitted light followed by a gradual decay. Now, the excitation of the substance does not involve electromagnetic radiation and no monochromators are needed. So, instead, the excitation energy comes from a chemical or electrochemical reaction. So, mao gyud ni ang pinaka uh, basic, something like that, na difference between fluorescence and phosphorescence ani kay chemiluminescence. Kaya sa inyong chemiluminescence, dili necessary na naay radiation na present, dili kailangan na naay, or even during measuring of the light na absorbed by your chemiluminescence, dili kailangan og monochromator. Kaya sadyang chemical reaction lang yun niya ha. So, again, to emphasize, excitation energy comes from a chemical or electrochemical reaction. So light signal is measured against a completely dark background. Now, going back sa kato kong giingon na ano kailangan man yun i-break. Your glow stick is actually like this one. Sa makita ninyo, nan murag na din na siya duha ka compartment and each of their mo na ay inside the portion kani and napo din ni siya outside the portion. And each of this compartment na din na siya different na chemicals inside. So that is why it is necessary to break that glow stick para na interaction between those two different chemicals na present and thus creating or glowing or creating light. So, nga na siya ka-amazing. Now, na ako ipakita ng video sa next na slide, but actually, dili yun siya ingani ka-important. Gi-include lang yun ako siya just for you to see kung unsa ka-amazing daining mga chemical reactions na pwede buhaton causing your different substances to glow. So, optional na ning next na video ha. So, it's up to you if you want to skip. Pwede lang ninyo na siya i-skip. Walay problema. Pero i-play lang gihapon ako siya. Actually, nalingaw gigwani na part. So, I hope na murag ma-amaze or ma-enjoy po dyan ninyo. Okay? Okay, next. Na-amaze mo or ako lang ang na-amaze? So anyway, so going back, uh, rather moving forward, so now let me present to you the advantages and disadvantages of your chemiluminescence. So starting with the advantages, uh, chemiluminescence could actually detect up to a sub-picomolar na level sa inyuhang level of concentration. Eh, di ba grabe na biyan nakababa? So I think you could already relate to that, di ba? From your moles to millimoles to micromoles, unsa na lang kaagyo ni kagamay ning sub-picomolar. So chemiluminescence is also fast, di ba? Kay flash type reactions lang biya dayon ni siya light. Oh, and that light is only measured for about 10 seconds. There is ease of use. Okay, you only need to mix your chemicals, and then very simple ang instrumentation. But the disadvantage of your chemiluminescence is that impurities can cause a background signal that degrades sensitivity and specificity. So, kalalang po na ang atuang bantayan. Okay. So now we proceed with your nephelometry and turbidimetry. Now, sa katong luminescence ninyo, what we are talking about there, di ba, is emission of light. By this time around, we will focus on light scatterings, since this is what nephelometry and turbidimetry is all about. Now, light scattering is a physical phenomenon that results from the interaction of light with particles in solutions. Since there are particles, there are substances that is not able to absorb light or that is not able to absorb energy. What happens here in your nephelometry and turbidimetry is kumbaga murag gina-bounce back nila causing light scattering. So unlike fluorescence emission, the wavelength of the scattered light here is the same as that of the incident light. So, what is the difference now between nephelometry and turbidimetry? As mentioned, di ba, both light scattering, but there are actually difference in terms of the principle behind each of these analytical techniques. So for nephelometry, it measures the amount of light scattered in a particulate suspension at a 90-degree angle. And it is very useful in terms of determining the concentrations of solutions that contains particles too large for absorption spectrometry. But basically, the second statement is actually, kanina second statement, this is actually applicable to both nephelometry and turbidimetry. And that is why we have these analytical techniques because there are particles that are really very large na dili na gyud kaya i-measure sa inyuhang absorption spectrometry. How about turbidimetry? Now, turbidimetry measures the amount of light blocked in a particle solution. Now, from the word turbid, remember turbid means cloudiness or haziness sa inyuhang solution. So meaning, since grabe ka cloudy sa inyuhang sample, pag inyuha ng mag-direct mo og light ana, di ba? Wala man dyan mo pass through na light sa other side because it is being blocked. And that is actually the principle behind turbidimetry, amount of light blocked. And so, we would expect that if there is increased concentration here of that certain substance here in your sample, there would be a decrease in your light transmission. So the amount of light blocked depends not only on the concentration but also on the size of your sample. And here, sampling handling becomes critical. Now, why is the sample handling of turbidimetry becomes critical? Since the particles here in your turbidimetry, or actually in your sample, kaya diba, it is too large and uh, it is too large, so the particles tend to aggregate with one another. And since dako man siya og size, so meaning bugat pud siya, so dali kay mag-settle out or mag-settle down dayon ang inyong suspension. So that is why before measuring substances, here in your turbidimetry, you really need to mix your samples well first. Okay, para to prevent na miscalculate or mali na hinun mo kung measure kay tungod nag-settle down na lang yun ito ang inyuhang suspension. So again, just to emphasize, nephelometry, light scattered at 90-degree angle, apil na siya. And then here for turbidimetry, that is light block. So let me just explain further the difference between turbidimetry and nephelometry. Now, again, both sila large particles. The difference here sa inyuhang turbidimetry ug sa inyuhang nephelometry, pag si turbidimetry, though large ang particles, pero grabe pud ka extensive yung scattering. Na kung i-drawing man nato na siya, so kunwari beaker ni siya, as in ang particles ninyo, as in grabe jud pud ka dikit, dagko kaayo, and ang again, scattering is very extensive. Na tipong kay tungod, nag-hazy na ang inyong sample, kay tungkol sa kadagko sa inyong particle and sa kadaghan po sa iyang concentration. Now, once na naamoy light, kunwari this is your light, diba, di kay ko how to drawing ha, kunwari mo ninyong light, and since pag adto sa light diri, it is not able to pass through already because of the haziness and cloudiness of your suspension, particles tend to block, and therefore, diba, diri ana part, wala jud na light na mag-pass through. While in your nephelometry, too large ang particles, but very low ang concentration. So what happens here, kunwari kani, mga dagko kaayo na particles, what happens here, if naamoy i-introduce ana na light, dire, ang tendency ani sa inyong nephelometry, pag-agi sa light sa taga-particle, it tends to scatter it out. Agi sa particle, scatter. Agi sa particle, scatter. So that is why, di ba, as mentioned kaganina sa principle sa inyuhang nephelometry, light scattering. And that is why we will place your detector here at a 90-degree angle. So for this portion, mga add-ons lang ni siya na or additional na information about turbidimetry and nephelometry. So as you can see, ang ipinaka gusto na ko tandaan ninyo diri sa turbidimetry na part is this one. The higher the turbidity, the smaller quantity of light being transmitted. While here in nephelometry, the intensity of the scattered light serves as a measure of the turbidimetry. And in turbidimetry, in terms of what specific instrument or how it could be measured, pwede lang ta actually bugamit og spektro. Since ato lang mang tan-awon diri if naadyoy di ba katong if naadyoy decrease sa inyuhang light transmission. But here in your nephelometry, you really need to have a different na instrument to be used for its measurement. It could either be a nephelometer or a nephelometric turbidimeter or meter. You can use spectrophotometer as stated here, but a special attachment is required for your nephelometry. Okay? So, ato nang i-set up ang uh, inyuhang uh, turbidimetry, sorry, turbidimetry ug nephelo, so diri ni siya. Since again, turbidimetry, what we are trying to look at is the decrease in your light transmission. So, ang iyahang detector, lang po diri, straight line lang. But since here in your nephelometry, what we are trying to look at is the light scattering, kaya it could either be here sa forward light scatter or here at a 90 degrees. Di ba again, light scattered ba aning naa diri sa inyuhang side? Ba mga lights na nag-scatter meaning naa sa side. Kaning naa diri sa inyo straight line mo ba na inyuhang transmitted light. So, what are the components of your nephelo and turbidimetry? For nephelometry, what you need is a mercury arc lamp. For turbidimetry, pwede na tungsten lamp. Scattered light is measured for nephelo, light transmitted for turbidimetry, measured at 90 degrees. For turbidimetry, measured in straight line. Then, for the detector, your photomultiplier tube for nephelo, pwede na photocell for your turbidimetry. So again, recall once again, unsa ning photo multiplier tube and unsa ni si photocell. Nani siya sa inyuhang spectro na part, I guess, na introduce. So what are the different factors that affect scattered light? Syempre, number one, it could be your particle size. Diba? The smaller your particles, the more scattered ang light. It could be on the concentration of particles, as what we have discussed in your turbidimetry. Since increase kay ang concentration and then grabe ka compact, so on tendency, wala na kayo light na matransmit, wala na pud kayo light na mag-scatter. And then molecular weight of your particles, and then your wavelength dependence. So these are just some factors that could affect your scattered light. Now there are actually three types of scattered light. So we have your Rayleigh, your Me, and your Rayleigh Debye. Now, if you try to search sa YouTube ba or how to pronounce this properly, actually daghan klase-klase man siya, naiuban na Rayleigh, naiuban na Rayleigh. So syempre Pinoy man ta, so muna Rayleigh, okay na kay it's very weird for me to pronounce it as Rayleigh or Rayleigh. So dito Rayleigh, Me, and Rayleigh Debye. So starting with your Rayleigh. Now, Rayleigh scattering happens if the wavelength of light is greater than the particle size. And since the wavelength of light is greater than your particle size, the scattering now of your light is symmetrical, just like what you see here in this image on the left side. And for you to better understand Rayleigh scattering, Rayleigh scattering actually answers the question as to why the sky is blue. So for the next slide, we'll present to you a short video lang po just to explain further the reason why sky is blue and unsa diining Rayleigh scattering. Actually, it is a very interesting na video for me to understand Rayleigh scattering and to understand why blue man gyud ni ang color sa ato ang sky kay for sa akong pagkabalo man good kids, diba murag ang nahibalan man gud ako is that it's the reflection of the sea. But actually there's a different reason as to why. So kindly watch this video.
Some of the common questions that kids ask are, why is the sky blue while the clouds aren't? Why is the sun yellow? And why does it turn reddish-orange during sunrise and sunset? These questions might look difficult to answer at first. However, the physics behind them is not difficult at all. There are two things that play an important role in giving a color to the sky. One is the atmosphere of the Earth, and the other is the sunlight, of course. So we need to know more about these two first. The white light coming from the sun is a mixture of 7 primary colors, and each colored light has a corresponding frequency and wavelength associated with it. The violet colored light has the shortest wavelength of all, while the red one has the largest wavelength. And what forms the Earth's atmosphere? The Earth's atmosphere is mainly composed of gases, dust particles, water droplets, and water vapor. Among the gases, nitrogen is present in abundant quantity at around 78%. It is followed by oxygen, which is approximately 21%, and the remaining is filled with the likes of argon, carbon dioxide, and other gases. First, let's see what happens when the sunlight falls on these air molecules. When sunlight strikes these molecules, it gets scattered. Scattering is a process in which the light is absorbed by the atoms and re-emitted back in various directions. However, not all the light is scattered equally. The amount of light that will be scattered is given by the Rayleigh law of scattering. It says that the amount of scattered light or the intensity of the scattered light is inversely proportional to the fourth power of the wavelength of a wave. I is inversely proportional to lambda to the fourth power. If the value of lambda increases, then the intensity will be lower. If its value decreases, then the intensity of scattering will be more. Lesser the wavelength, more will be the scattering. So now, I want you to tell me, among the 7 colors of sunlight, which one will be scattered the most? Yes, the light of the color corresponding to the smallest wavelength will be scattered the most. So blue, indigo, and violet light will be scattered most by these molecules of air. And when this light travels to our eyes, the sky appears blue to us. But wait, the violet light has the smallest wavelength. Then why doesn't the sky appear violet or even indigo for that matter? It is true that the sky scatters the violet light more than the blue light. However, we don't see violet sky, do we? What's the reason? The following graph tells us how much of a particular wavelength is emitted by the sun. Observe the graph well. As you can see, the sun emits more blue and light bluish light compared to the violet light. Hence, more blue light is scattered by the air molecules, resulting in the blue color of the sky. And another reason why we cannot see violet light is because our eyes are more sensitive to blue light than to violet light. So this was about how the gases present in the atmosphere scatter light. Do dust particles and water droplets also scatter light? Yes, they do. They scatter light as well. However, their size is comparatively much bigger than the size of the light waves, and hence they scatter all the colors of light in equal amounts. So the white light which is entering the cloud or the dust particles emerges out as white light again. Hence the clouds appear white. There's one last question we need to answer. Why does the sun appear reddish during sunset and yellow otherwise? We will see that in our next lesson.
Nabitin mo, kids. Anyway, so, ayun. Isn't it amazing na in such a way, our eyes is actually very sensitive lang day to blue light kay. While I was watching the video, katupod actually anikam or nisulod sa ako ang mind na, 'di ba? Violet actually has the shortest wavelength. So why does the sky, 'di ba, dili siya nag-appear color violet? So kato lang po siya. Actually, I tried to search why mas sensitive ang ato ang eyes to blue. But anyway, wala ko'y nakita na tarong na explanation. So we do not need to talk about that. So I hope na nag-gets po to siya na part about your Rayleigh scattering. Next, we have your me. Me here is the opposite to your Rayleigh, in which the wavelength of light here is lesser than the is less than the particle size. Now, what happens here is that light scatters backward but appears forward due to destruction out of phase background scatter. And this is how it would look like. Now, me actually answers the question as to why clouds are white. And it will further explain to us this second statement regarding due to destruction of phase background scatter. So mas masabtanan ninyo siya later on. So kindly watch this video.
You ever thought about it? Why are clouds white? Sky is blue, sun is yellow, but clouds are white. Now, check this out. So the sun emits all of the colors in the visible spectrum. Now, when you combine all of those colors, you get white. So let's start with the light first, right? So the sun emitting white light, if you will. Now, the clouds, they are made up of tiny round water droplets, very, very, very small water droplets. Now, when that sunlight, that white sunlight, passes through those tiny droplets, they are scattered in all directions. So let's shrink that back down there into the cloud. So when you get sunlight, remember, all the colors of the visible spectrum, which is white, they hit the water droplets in the cloud, and they're scattered in all directions, and that's why clouds are white.
So you see, because of the light scattering in all directions, na kumbaga from one water droplet to another, nagkabangga-bangga, then na-retain gihapon ang whiteness sa color, ang katong white na light na gikan sa inyuhang sun dito sa inyuhang clouds. And that is actually the explanation behind our second statement a while ago na naay destruction, katong destruction out of phase. It's because of that. Water droplets tend to scatter light, and then since bounce back from one another, then na-retain ang color white. So now we go to the last type, which is your Rayleigh Debye. Now, here for Rayleigh Debye, wavelength of light is actually equivalent or the same with the particle size. So what happens here is that there is more forward light scatter, and the best example for this is your antigen-antibody reaction. Now again, just to emphasize, ang sa inyuhang Rayleigh Debye, di ba, if you try to look at this image, actually it has almost the same image with your me. But here, if i-try ninyo side to side, si Rayleigh Debye ug si me, mas daghan ang forward light scatter gyud sa inyohang Rayleigh Debye. Actually, trying to search about Rayleigh Debye, kung unsa gyud siya all about, but wala kaayo ko'y makita man good. The only thing that was mentioned is that an example of it is your antigen antibody reaction. But even in this example, wala pa gyud siya further gi-discuss. So mo na pasensya kids, ang ako lang yung ma-emphasize sa inyo ha, aning Rayleigh Debye ninyo is these two statements. Na the wavelength of light is the same with your particle size, and this what happens here is that more forward light are being scattered. Okay? So, we'll cut our video lecture here, but at least naputay gamay na break. Then we'll proceed with your chromatography sa next. So, break sa tagamay, and then I hope na nagets ninyo ang katong ato ang first part sa ato ang lesson. So, thank you kids!